All right, so welcome to this class. Okay, so this is chemistry. Earlier in the day, I sent some videos on significant figures and uncertainty. Okay, so I hope you guys are watching those videos. Okay, I really hope you are. Okay, so we are going to be having like a double class. Some of the classes will be pre-recorded and shared to you, and then some of them will be live like the one we are having right now. Okay, so in today's class we are looking at atoms, ions, um, molecules, and isotopes. Okay, so those are the three things that we are going to be looking at today, and then I've outlined uh, the objectives here. Okay, so we have subatomic particles. We are going to talk about them. So I know you know the subatomic particles. Okay, so those electrons, protons, okay, the neutrons, those are subatomic particles. So we're going to talk about them. We're going to talk about the ions and their charges. Okay, and then we're going to discuss the atomic number, the mass number, and finally we are going to see how we can find this relative atomic number using what? Isotopes. Okay. All right, so this is the roadmap for today's lesson. So we start with the subatomic particles. Okay, so according to the modern view, of the atom, okay, they say that the atom consists of two regions. Okay, so it consists of two regions. So the first region, okay, is the nucleus. Okay, the first region is the nucleus, and then the second one is what we call as the electron cloud. Okay, electron cloud. So when we draw this representation of the nucleus there, I've drawn it in red. Okay, and then I can draw the cloud of electrons around this what? Nucleus, like that. So this cloud of electrons, okay, is what we are going to be referring to as the shells around this nucleus. Okay, so inside this nucleus we have protons, okay, the ones I've indicated in yellow, and then we also have the neutrons, the ones I'm putting in blue, like that. Okay, and then in the energy levels, these circles that I've drawn around this nucleus in red, okay, we are going to have electrons, like that. Okay, you can find an electron there, um, some electrons there. Okay, so this is the modern view of the of the atom, I mean. Okay, they say that it consists of two regions. One of them is the nucleus, where you can find the protons and the neutrons. Okay, and then the other one is the electron cloud in form of the electron what? Shells. And in those shells we are going to find the electrons. So this means that we have three subatomic particles. Okay, so the first one is, yes, okay, so what are you seeing on my screen? Yes, in the periodic table. Okay, let me try to reshare my screen. So stop sharing, and then what can you see now? Solutions. All right, I'm sure you can see board now, right? What are you seeing now? Yes. You can see the subatomic particles and the circles I was drawing. Yes. All right. Sorry for that. I thought you were able to see. All right. So in summary, I was saying when you talk about the subatomic particles, okay, then we have to understand the modern view of the atom. Okay, so they say that the atom consists of two regions. Okay, the first one is the nucleus, and then the second one is the electron cloud. So in this nucleus, the one that I've drawn in red here, okay, this one here, you are going to find the neutrons and the protons. So I indicated the protons by the yellow there, and then the neutrons with the blue. And then around this nucleus we are going to find those electron shells, okay? And in those shells we are going to find what? Electrons, okay? So from that we can tell, or we can see, that we have how many subatomic particles? 3, okay? So the first one, we have the electrons. Okay, we have the electrons, and then the second one we have the protons. Okay, and then from the protons we have the neutrons. So these 3 subatomic particles have different charges. Okay, we know this from our grade 12. So we know that these protons here are positively charged. So we are going to say the protons are positively charged. Let me use another color. So the protons are positively charged, so they have a positive charge. Okay, the electrons have a negative charge, and then these neutrons here have no charge. Okay, their charge is 0, they have no charge at all. Okay, so depending on the type of subatomic particle that you are talking about, okay, it's going to have a different meaning. Okay, so let me explain the different meanings of these 3 particles, okay, because most students, they get it wrong. Okay, so when you talk about the protons, okay, so the number of protons in an element or in an atom, okay, will give that atom its identity. Okay, so you should listen very carefully here. So the number of protons, okay, called the proton number, or some people say the atomic number, okay, it gives the atom its identity, okay, and this number does not change. Okay, we are going to say does not change. Okay, does not change at all. Okay, so that means that this proton, the number of protons, they're like an identity for an element. Okay, so for example, if we talk about oxygen, okay, oxygen has 8 protons. Okay, so you will never find another element with 8 protons. Okay, you will never. As long as that element has 8 protons, then we say that that element is what? Oxygen. And then I can also give an example of carbon. Carbon has 6 protons. Okay, so meaning that you will never find another element with 6 protons. It is just carbon. Okay, so whenever you are given an element and they tell you that element has 6 protons, just know that that element is what? Carbon. So the proton number does not change, and it gives the element its what? Identity. And then we can talk about the electrons. Okay, before I talk about the electrons, let me talk about the neutrons. Okay, so the neutrons, we said that they have no overall charge. Okay, their charge is 0. Okay, so what is their importance? Okay, so their importance is that they contribute to the mass of the element, or the mass of the what? Atom. Okay, so this is their work. So the number of neutrons can change. Okay, and when this number of neutrons changes, that is when we end up with isotopes. Okay, so if you have an element, okay, which has 2 different numbers of neutrons here, then we say that that element has what? Isotope. It has isotopes. So the number of neutrons can change, okay, and when it changes, it causes that element to have what? Isotopes. And then what is the importance of the neutrons? They contribute to the mass of the atom, okay, or to the weight of the atom. All right, so that's very important to take note. And then now we can talk about the electrons. Okay, so these electrons, we said they have the overall charge of what? A minus. So these ones here are important for chemical bonding. Okay, important for chemical bonding. Okay, so whatever reactions these elements, these atoms are going to be involved in, okay, it will be the work of the electrons. Okay, and these electrons can also change. Okay, the number of electrons can change, and when the number of electrons changes, we form what we call as what? Ions. Okay, so you can see the difference. I've clearly outlined the difference between these three subatomic particles. Okay, the proton is for identity and the number does not change. The neutrons, okay, they are important for the mass of the atom, and when they change they form isotopes. And then the electrons, okay, they are important for chemical bonding, and when they change they form what? Ions. Okay, so those are the three subatomic particles, okay, that you have to know. All right, and then another thing that you need to know is that, I think I've already mentioned anyway, the number of protons, okay, in an atom is called what? Okay, the number of protons in an atom is called the proton number. Okay, so the proton number there. So this proton number is also called the atomic number. Okay, atomic number. So this atomic number, okay, listen very carefully. In a neutral atom, okay, which means an atom on or an element which is not an ion, okay, in a neutral atom, the number of protons is always equal to the number of what? Electrons. So if I consider oxygen, for example, and then I say, of course, the proton number for oxygen is 8. Okay, if this oxygen is neutral, it has no charge there like -1 or maybe plus whatever, okay, then the number of protons and the number of electrons are going to be the same. So we're just going to say 8 there. Okay, so in a neutral atom, okay, take note of the word neutral, the number of protons and the number of electrons are always the same. So in the questions that are going to be coming, they're just going to be telling you the proton number. Okay, they're just going to be telling you the proton number, and then they expect that you know that since it's a neutral atom, it's going to have the same number of what? Electrons. Okay, so this is one of the important things that I wanted to highlight. Okay, so we've talked about the subatomic particles. Okay, now we can talk about the ions and the charges. Okay, so let's get, for example, the same oxygen that we've been using. Okay, so we know that this oxygen here, it has the proton number of what? 8. And then when we get the neutral form of this oxygen, okay, we see that even the electron number there, or the number of electrons, okay, will be the same. It will just be 8. So when does an ion form? Okay, so that this atom now has a charge. Okay, so the ion is formed when a neutral atom either loses an electron or it gains electrons. Okay, remember the protons do not move, but these electrons can move. Okay, so a neutral atom can either gain electrons or it can lose them. Okay, so it's either way, it can gain or it can lose. So for example, this oxygen here, okay, it has the tendency to gain electrons. Okay, it has the tendency to gain electrons. So when it gains, because these electrons here, when we write the electronic configuration, okay, it will be 2 and then 6. So we want to fill this 6 here by completing the octet rule. So how do we complete the octet rule? We know that the octet rule states that in that shell we should have 8 electrons, right? So it already has 6 there, so it will just easily gain 2 electrons, okay, so that it has the electronic configuration 2.8 there. So this oxygen, when it gains electrons, okay, it gains 2 electrons, then it means that the oxygen will become what? 2 minus. Okay, it will be charged now. It will become an ion, which is 2 minus. So why is it becoming an ion? Because now it has an excess of the negative charges. Remember, when it is neutral, the protons and the electrons are equal, so the charge is what? 0. It is balanced like that. But now we've added an extra 2 electrons, and we know that electrons are negative, so it means this oxygen here will go on and to become a what? A negative. And then for example, if I have sodium, okay, if I have sodium like that, okay, so what is the electronic configuration of sodium? So when you go on this periodic table, I hope you are able to see the periodic table. So if I go on this periodic table and I go on sodium, okay, we are going to see the atomic mass there is 11. Okay, so when we write it in electronic configuration form, it will be 2.8.1. Okay, so all the atoms want to achieve the octet rule. So the octet rule states that in this second energy shell, okay, we should have 8 electrons. So for this sodium atom, it is very easy for it to lose this one electron here, okay, than to gain 7 electrons. Okay, so when it loses this electron, okay, what happens to it? It becomes positively charged like that. Okay, I hope you are getting it. So if you have any question, please feel free to ask. Okay, so it becomes a positive here because it has lost one of its electrons, but the protons have remained the same. So the protons are 11, and then when it loses this one electron like that, you remain with 10 electrons. So 11 minus 10, it will give you this positive charge here. Okay, so that's how the electrons are formed. Okay, so they can give you an element, they just say K plus like that. Someone has a question?
Yes.
Yes, please.
Okay, a question. What if in an instance where we had 2, 8, then for example, let's say 3.
Okay, so 3, yes, so even if we had 3 here, it's still, this 3 here will be lost like that. So we see that when we talk about the aluminium atom, okay, it has 3 in its last shell there, so it will lose. So the trend is like this. I think I didn't explain like this. Okay, so if you have an atom, okay, and then in the last shell you have 1, 2, 3 electrons, okay, these electrons tend to be lost. Okay, and then when you have the last energy shell having number of electrons like 5, 6, 7, these here tend to gain electrons. Okay, and then these 1, 2, 3 tend to lose. So if it's 2, 1, 3, then it will be lost. And then when it is 5, 6, or 7, then it will gain. Okay, and then when it is 4, okay, there is nothing that will happen because this here cannot form it cannot form an ion, because the ones that have 4 in their last energy shell, they are metals. I mean, they are non-metals. Okay, so these ions can only be formed by metals. Okay, all right. Okay, so that's how the ions are going to be forming and the charges are going to be forming. Okay, so let me give one example here before we go to another concept. Okay, let's say we have calcium. Okay, let's say we have calcium. So calcium here, okay, how many protons does it have? Okay, in its neutral form, how many protons? Okay, so you just go to the periodic table here and then you look for calcium. So calcium is here. So calcium has 20. Okay, it has 20 protons. So if it has 20 protons, it means in its neutral state, it will also have 20 electrons. And when we put these 20 electrons in an electronic configuration, it will be 2.8.8.2 like that. So this calcium will tend to lose these 2. Okay, so when it loses these 2 electrons, then it becomes Ca2 plus like that. Okay, because it has lost 2 electrons, so it has become a 2 plus like that. Okay, so that's how the ions can be forming. Okay, so you can have different questions testing you on different things. Okay, they can just write maybe magnesium 2 plus. Okay, and then they ask you how many protons do we have in this, and then how many electrons do we have in this. Okay, and then you can be able to answer if you have this knowledge here. So when you say 2 plus here, you know that okay, this element lost 2 electrons. Okay, if the charge is minus, okay, for example, I can have Cl minus like that. Okay, they ask you to find how many electrons would this element have, or will this ion have. Okay, you see the negative charges there, and then you conclude that, oh, since this charge is negative, it means this atom or this element gained an extra electron. So that's how we'll be interpreting the charges and the ions. All right, and then I can go to the next thing here now and talk about the atomic and the mass number. Okay, so I've talked about this atomic number a bit. We said the atomic number is the number of what? Proton. Okay, the number of protons is the atomic number. And then the mass number, okay, this mass number here is the number of protons plus the number of neutrons. Okay, so when you add those particles that we said were present in the nucleus, okay, we had protons there and neutrons. When we add these, okay, you add the number of protons to the number of neutrons, okay, you get what we call as the mass number. So this mass number, okay, is also called as the relative atomic mass. Okay, mass number is also called as the relative atomic mass, and we are going to look at this relative atomic mass when we are looking at the isotopes. Okay, so when you go on your periodic table there, guys, you find something like this, which is a key. Okay, so it will tell you that what they will put in between there will be the symbol for that element. Okay, on top there of the element name, and then here on top you have the atomic number or the number of protons, and then down there we have the atomic mass. So the atomic mass is the same as the mass number, and it's also the same as the what? The relative atomic mass. So you can see, for example, this is boron here. Okay, this is boron here. So on top there, you can see this number 5. So this 5 here represents the atomic number or the number of protons. And then this number down here is the atomic mass or the mass number. So now, an important thing is to note there is that, okay, all the mass numbers on the periodic table, okay, all the mass numbers on the periodic tables, they were found, okay, by finding the relative atomic mass of all the isotopes of a certain element. Okay, so this boron here, for them to find this 10 here, it means they added all the masses for all the relative masses for all the isotopes of boron. Okay, so we are going to later see how we can calculate this number here. Okay, it's very simple. It's a very simple formula that we're going to be using to calculate this. Okay, so that's what we are going to be using there. Okay, so make sure you know there. Okay, so sometimes some books they have a symbol there, X. Okay, they say this is the chemical symbol, and then you have atomic number there, and then down there you have atomic mass. Okay, some periodic tables they have the atomic mass on top here, and then the mass number, the atomic number, it's down there. So it's very important, whatever periodic table that you are using, okay, check for the key. Okay, check for the key so that you know how they are representing the different atomic numbers there. Okay, so always check this key when you open the periodic table. So for this one specifically that I'm using, we have the atomic mass down and the atomic number what on top there. All right, so now we can solve an example on what I've explained. Okay, so we have this table that has different columns, okay, with different things. So the first column here, it has the chemical symbol, okay, and then here I have number of protons in the nucleus, number of neutrons in the nucleus, number of electrons, and then here we have the mass number, here we have the atomic number, and then here we have the net charge. Okay, so you can see that we've been given some of these numbers here, and then they want us to fill in the blanks. Okay, so based on what up when filling all these that we have here. Okay, so let's start with the number 1. So remember I said the number of proton. Okay, number of proton is the identity for the what? For the element. So for us to find the symbol that we are going to put there, we have to identify the element. So how are we going to identify that element? We are going to look at the number of protons. Okay, so the number of protons is 35. Number of protons is 45. We're going to go periodic table and look for an element which has what? 35 protons. So you open your periodic table here, and then you look for an element which has 35 protons. So 35 protons, I can see it is here. Okay, so let me put it. This one here, we can see 35 on top there, right? So boron, I mean bromine there. Okay, bromine has the proton number 35. So we get its symbol, which is what? Br. So when we go back here, we're going to say, okay, since this is 35, it means my symbol there is Br.
You can't see the periodic table.
Periodic table?
No.
Okay, but anyways, yeah, so you just go on the periodic table. Once you go on your periodic table, okay, I think, let me share the entire window. Okay, let me share. Okay, let me share the entire window so that you can be seeing my. Okay, are you still able to see my screen?
Yes, we are seeing your screen.
Okay, let me try to go to the periodic table and see if you are going to see it. Okay, are you seeing the periodic table now?
No.
You're not seeing it?
No.
Okay.
We are seeing it now.
Equals to the number of protons plus the number of neutrons. So from here, the number of protons is 35. The number of neutrons is 44. So we can find the number which is here. Okay, so we are going to say 35 plus 44. That I'm getting a 79. So we are going to put a 79 here, like that. Okay, and then here they're saying atomic number. Okay, so what do we put under atomic number? What do we put under atomic number?
Put the proton now.
Exactly. Okay, so the proton number and the atomic number are the same. So we're going to write 35 here. And then the number of electrons here are 36. So they are the ones that are going to help us determine the charge here. So we have 35 protons and 36 electrons. So how many, what will be the charge here, I mean?
It's going to be a positive.
It's going to be a positive. Okay. Why do you say it's going to be a positive?
And actually, it's going to be a negative.
Exactly. Okay, it's going to be a negative because here we have 35, here we have 36, so it's actually going to be negative 1. Okay, so we have positive 35. Okay, so I'm putting a positive here because it's the number of protons, and then I'm going to say minus 36. I'm putting a minus here because this 36 is the number of electrons, so this here is going to give me a minus 1. Okay, so you put your charge here as 1 minus, like that. Don't put your charge as minus 1, guys. Okay, don't put your charge as minus 1. Put 1 minus or 2 minus or whatever. Okay, that's how you represent a charge. If you are putting 1 minus, then this is not a charge. I mean, minus 1 is not a charge. So you have to put 1 minus, 2 minus, or whatever minus. Alright, so we've answered the first one there. Okay, we've answered the first one there. So let's try to also fill in the second row there. So the second row, what do we have? Okay, so in the second row there, we don't have the proton number here, but we have the number of neutrons, the number of electrons, and the charge here. So this charge here is negative, okay, and it's 2 minus. So if the charge is 2 minus, what does that mean? Anyone?
Gain two electrons.
Okay, so it means this one gained 2 electrons, right? Okay, so if it gained 2 electrons, okay, we are going to go here where we can see the number of electrons. So we have 54 electrons, and then since we have a 2 minus there, it means this atom gained 2 extra electrons. Okay, so it means the original number of electrons were what? 52. Okay, and then it gained 2 to what? To 54. So the original number of electrons, we know that they are always equal to the original number of what? Protons. So we can find the number of protons like that. So here we're going to put 52. Okay, and then from there we can find the mass number. So we just add 52 plus the number of electrons, which is 76. So we are going to get 128. Okay, and then the atomic number is the same as the proton number, so this is 52. And then the symbol here, okay, we go back on the periodic table and check which one has what? This as the atomic mass. So that's 52. So you come here on your periodic table, we see that the 52 is here. Okay, so 52 is tellurium here.